In this video, we look at the average and instantaneous rates of change of trigonometric functions. When we talk about average rate of change in terms of trigonometric functions, basically the average rate of change is the same that it has been for all of the other functions that we've looked at. So for example, if we look at this sine curve, the average rate of change between 2 points is just the slope of the secant. So I'm just going to choose a couple of points here, and we'll just draw a line through those 2 points. When we want to find the average rate of change from x equals, let's say 0 to x equals pi over 2, call that one pi over 2. Then we just draw the secant. We find the slope of the secant the way that we always have. And just a reminder, the way that we've done that is by saying that the average rate of change, so the average rate of change is equal to f at x plus h minus f at x all over h. And that will still apply, again, we've talked about this many times before, applies for trig functions as well as others. Just a reminder too that another way we can do this, the average rate of change is just the slope of the line connecting those 2 points. We could find the two y values and find their difference. Oh, sorry, should be a 1. So y2 minus y1 over the difference in the x value, so x2 minus x1. So again, all of that's still going to work. Everything that we've talked about finding average rate of change stays the same. Now, one of the things that becomes a little more complicated when we're finding the instantaneous rate of change is that we don't actually have the tools yet to be able to find the instantaneous rate of change exactly. So what we're going to do here for that is we're going to estimate by finding the average rate of change between the point of interest and a point close by. So for example, if I want to find the instantaneous rate of change at, let's say, this point right here, whatever it happens to be, that point right there. Remember, the instantaneous rate of change is the slope of the secant. So we draw in a secant, and we want to find the slope of that line. Well, the way that we're going to do that is we're going to choose another point that's close by. How close? Well, it depends how precise you want to be, but we're going to choose a point. Oh, hang on a second. Let me draw this. I'm going to draw it a little bit further away just so that you can kind of see what we're doing. But we're going to estimate the instantaneous rate of change at this point by drawing a straight line between the point that we're interested in and a point that's really close. And typically, we'll use that distance between those 2 points. We'll call that our h value. And we'll say that h is equal to 0.0, oh, I lost my decimal there, 0.1. And so really when we find the instantaneous rate of change, we're just going to approximate it as being an average rate of change. Now some of you might wonder, why are we going to the right of the point and not the left? And the answer is we could very well go to the left. In fact, you know, some students like finding a more precise average, and they'll find the average going to the left, the average going to the right, and kind of average them out. I don't think we need to do that. The goal here is just that you understand what an instantaneous rate of change is and how to calculate it. So again, here we'll look at the instantaneous rate of change, and we'll say that it's approximately equal to f at x plus h, except our h we've already determined will be 0.001. And then from that we will subtract f at x and then divide by h. And again, h in this case is going to be 0.001. So that's the only difference here. So we don't have to go through and it is an estimate, but that's okay. You'll learn a little bit later, if you continue on after this course, you'll learn a little bit more about how do you find the actual instantaneous rate of change for a trigonometric function, but we just don't have the time to kind of get into it in this course. All right, let's look at an example. I'll do an instantaneous rate of change example since it's very similar to the average rate of change. Here we'll estimate the instantaneous rate of change of this function, sine of x plus pi over 2 plus 4, and we're going to estimate that at x equals 5. So what we'll do is we'll just go ahead and calculate. We could substitute, and we've talked about this before. You know what? I think I'm going to do x equals 3. Well, I'm going to do x equals 3 instead of 5. I just realized I miswrote this. So why don't we go ahead and find an expression for the instantaneous rate of change first, and then we can do our substitution. The advantage of doing it that way is that if you have to find a whole bunch of instantaneous rates of change, you've got an equation at the end that you could use. So the instantaneous rate of change here, as we said before, is approximately equal to f at x plus h minus f at x all over h. And we'll just fill in the information that we have already. So this will be approximately equal to the sine of x plus h plus pi over 2. Oh, sorry, that's a little bit messy. Plus 4, sorry, I almost forgot our plus 4 out the back end there. And then from that we will subtract, and I'm going to put this function f at x in brackets so we don't lose any negative signs. We'll do the sine of x plus pi over 2 plus 4. And all of that gets divided by h. So all I've done so far is substituted into the equation for the instantaneous rate of change, or for an estimate, I should say, of the instantaneous rate of change. And I suppose from here we can distribute, collect some like terms a little bit. We'll get the sine of x plus h plus pi over 2 plus 4. Now I'm noticing here, and you may notice this as well, we're going to have a plus 4 here, and when we distribute this minus sign, we're going to have a minus 4. So the plus 4 and the minus 4 will give us 0 in total. So really we'll get the sine of x plus h plus pi over 2 minus the sine of x plus pi over 2. All of that gets divided by h. And then again, we said h is going to be, when we do our estimate, just a reminder that h will be 0.001. Let me make that decimal point a little bit bigger. And so we can actually make that substitution, and we can substitute x equals 3 into the equation as well. So we may as well do that now. We can do both of them. Or if you wanted to use this a whole bunch of times, you could sub in the 0.001 and then sub in your x's after. But I think we'll just do it all in one shot here, just because I'm going to run out of room if I'm not careful. So we said x was 3 plus 0.001 plus pi over 2 minus the sine of 3 plus pi over 2. All of that gets divided by 0.0001. I think I had one too many zeros there. Try that again, 0.001. And we're going to plug that into the calculator, and I think if we do that, we should get a negative value, negative 0.14. So again, that's an estimate of the instantaneous rate of change of this function at x equals 3. Let me tidy that up a little bit. And we found that by finding an average rate of change between x equals 3 and 3.001, pardon me. So that's a fairly quick rundown about how to do rates of change with trigonometric functions.